What's up, O fans? It's Sam here with Olight Canada. Let's do a little science experiment. I've got this awesome little thermal imaging camera module, as well as 3 different O clips made out of 3 different materials. First off, standard aluminum, seen here in Olight Canada's Halloween edition. Then a solid copper O clip, which we know is going to fare very well in this test. But where things get very interesting is comparing these two against the SHOT Show exclusive O clip made out of OAL, Olight's new super alloy. We're going to see how this compares to standard aluminum, and we're going to see just how much better copper is at dispelling the heat. So at this point, I've turned all 3 O clips on in their maximum brightness, just getting things set up. And as my hands leave the frame, you can start to see those colors start to register properly in terms of the temperature of the O clips in front of us. Now, the aluminum one on the left, you're already seeing the heat get pumped into the aluminum. The OAL on the right seems to be heating up a little bit less quickly, and the copper in the middle isn't picking up any heat at all. Now, disclaimer, the O-clip isn't the most overpowered flashlight. Other Olights are going to heat up a lot quicker and a lot hotter, but the interesting part of this experiment is that all 3 of these are the exact same model, just with different materials. We could do the same test with an ArcFeld Ultra against an ArcFeld Pro. Those are 2 different materials, but they're not exactly the same model. Anyway, on the left here, you can see there's a lot more heat going in the aluminum, and the OAL seems to be not quite heating up quite so evenly. Now, take note of the flashing red cross on the right-hand side of the screen. That indicates the hottest part of the frame. And as we move to the side view, you can see the hottest part of the frame is the standard aluminum O-clip. Now, I'm no physicist, but I know the heat in the flashlight system comes from the emitter, and I know that the heat travels through the material in order to pull the heat away from the emitter and to vent it, essentially, to the atmosphere. So what we're looking at here, I think, is the aluminum holding on to more heat, the copper being able to conduct the heat away from the emitter and into the atmosphere more efficiently, and I think the O-clip in OAL is also doing a little bit more of that efficient conduction of heat into the atmosphere. Now, do I know exactly for sure that that's what that means? No, I don't. The other thing it could mean is it's pulling less heat out of the emitter itself and conducting that heat more poorly into the body material. So maybe more information is needed, but my conclusion is that the OAL does perform a little bit better. So there you have it, just one simple data point about the thermal conductivity of these 3 different materials when compared directly against each other in very similar circumstances in the exact same model. So after 3 minutes, the aluminum one got above 30 degrees. The OAL seemed to be doing a little bit better, dispelling that heat along the periphery, and the copper just completely unbothered. So there you have it.